Hello everyone. The next topic that we are going to understand from the instruction set in which the data transfer group we have done. The next is arithmetic group of instructions. As the name suggests, the instructions all belong to arithmetic operations. Let us see what the instructions are. Okay, the first instruction that comes under arithmetic group is AddR. So the meaning of AddR is add the contents of register to the accumulator and place the result back into accumulator. So that is how it is showing here. Accumulator is equal to accumulator plus R. As the operand is register, the addressing mode of this instruction is register addressing mode, and it is a single byte instruction. Here in this instruction, all flags may be modified. As we have seen here, it is written AddR. So what are the valid registers which we can use for addition is all the general purpose registers, which are 8-bit registers, that is accumulator, B, C, D, E and H and L. Okay, so you can have instructions like add A, which adds what? Accumulator to accumulator. If you write add B, it is going to add accumulator with B register. The addition of the two is placed back in accumulator. So if you see the example here, the example taken over here is add C. Means what? You are adding the contents of accumulator to contents of C register, and the result is stored back in accumulator. Okay. Okay, this example gives you how this add instruction is uh, internally operating and how the result is stored depending upon the instruction's result, depending upon the operation. What are the flags which are affected is elaborately shown in this example. So you can see here in this example, accumulator has 47H and C register has 51H, and the instruction that is going to be executed is add C. It means add the contents of accumulator to C register and the result to be placed in accumulator. So we have written here A, the value of A is 47. So 0100 0111, it is 47. 51 of content of C is 0101 0001. So when you add 1 plus 1, it is 0 carry 1. Again 1 plus 1 carry 1 and a 0 is the result. Again go back 1 plus 1. The result 0 carry 1. 0 plus 1 plus 0 is 1. And the other side again 0 plus 1 is 1. 0 plus 0 is 0. 1 plus 1 is 0 carry 1. 0 plus 0 plus 1 is 1. So the result of the addition of accumulator and C gives you 98H. So this 98H is stored in accumulator. So depending upon the operation and the result that is reflected in the accumulator, respectively the different flags are getting modified here. And with respect to this instruction, the addition of A with C register, you can see here the result is not 0, the result is 98. So 0 flag is not set, it is reset. So Z flag is 0. Next is parity. So you can see there are 3 ones in the result, which is odd parity. So if there are odd number of ones, then the parity flag is reset, which is equal to 0. Now you can see sign flag is the sign flag usually signifies the 8th bit over there. So 8th bit is 1, so sign flag is set to 1. Now carry, is there a carry generated? No, there is no carry generated. So carry is also 0. And you can see auxiliary carry is also not generated because D3 to D4, the addition is 0 plus 1, which is not generating any carry. That's why auxiliary carry is also 0. This is how you need to even interpret the meaning of the contents of flag register, and the other way, when some operation has been done, how that operation affects the flag register, we need to understand. Okay. Okay, the next instruction that we are going to understand is add memory. Means what? Adding the contents of accumulator to the contents of memory location, whose address is there in HL pair of register. So, how it is added? A plus within two square brackets, it should be HL. So, the result is stored in accumulator. So, Here the what is the addressing mode? Since the data is or one of the operand is in memory, so it is register indirect addressing mode. Okay, so the result is always stored in accumulator. It is a single byte instruction and all flags may be modified. And it is an example in which you need to consider the contents of HL pair, and at that address what is the data, and let the content of accumulator be something, add it and show the result into the accumulator as we have done in the last example. You need to do. Okay. Okay, the next instruction is ADI 8-bit data. As it is, you can see here, it is something, some immediate data has been taken into account. So what is that immediate data? It is a 8-bit data. So the meaning of this instruction is add immediate 8-bit data to accumulator. So 8-bit data is added to accumulator and the result is placed in accumulator. And you can see there are 2 bytes which are giving the full meaning of this instruction. One is the opcode, the other one is the immediate data. Okay, so that's why this instruction having 2 bytes as the length of the instruction. And the addressing mode, since there is an immediate data, so the addressing mode is immediate addressing mode. Okay, here the example is also given as ADI 25H. Means what? 25H is going to be added to the contents of accumulator. So for that you need to assume some data in accumulator, add that content of accumulator to 25H. Whatever is the result, that has to be stored in accumulator. Okay, that's how you need to show the example. Okay, and here the the addressing mode and the flags modified. All flags are modified. You can write it as all flags may be modified instead of writing all flags are modified, because depending upon the operation, some flags get modified and some are not modified. Okay, the next instruction is ADCR. Means what? You are taking care of the carry now. It is like your AddR, but to that you are adding one more thing, that is carry flag. Content of carry flag is also added. So accumulator is equal to accumulator, the content plus contents of register plus the content of carry flag. If carry is 0, 0 is added. If carry is 1, 1 is added. Okay, so the ADC R instruction is a single byte instruction and it is following register addressing mode, and here also all flags may be modified, and the valid registers over here are A, B, C, D, E, H or L. Any of the registers you can use it in the instruction. Again in the example you need to assume the data in register, in accumulator, and assume the content of carry flag also, and then add all the 3 and put the result in accumulator. That is how you need to show the result. Example, I mean to say. Okay, you can see the example of the same, how I have executed, or how is the example to be shown. See here, ADCR. So we need to consider, we need to assume some data. We have assumed accumulator as 98H, B as 18H, and carry as 01H. So all the 3 we are supposed to write in terms of binary, add them. What is 98? 1001, 8 is 1000. 18 0001 with 1000. 01 is 00000001. So you add all the 3. 0 plus 0 plus 1, 1. All 0, 0, 0. 1 plus 1 is 0, carry 1. So 1 plus 1 plus 1 is 1, 1. 1 here, carry 1. 1 plus 0 is 1 here. All zeros added 0 here. 1 plus 0 is 1 here. So 1, 0, 1, 1 is B and 0001 is 1. So the answer is B1H. So depending upon the result which is there after the addition, you need to write the contents of the flag register. So flag register, you can see here one thing, there is an auxiliary carry generated because 1 plus 1 is giving 0 as the sum and 1 as the carry. So this is where the auxiliary carry D3 to D4 the carry is generated. That's why we have shown auxiliary carry as 1, and there is 1 on the 8th bit. That's why sign flag is 1. There is no carry generated, that's why carry is 0. The answer is not 0, that's why 0 flag is 0. And parity is 1. Why parity is 1? Because the number of ones in the result are even. So even parity is 1. So that's why the content of flag register, you got it as 94H. Okay. Okay, the next instruction that we are going to understand is ADCM. What is the meaning of ADCM? Add the contents of the accumulator and memory along with carry. So A plus the contents of memory plus carry, result is stored in back into accumulator. It is a single byte instruction, as the one of the operand is the memory. That's why the addressing mode is indirect addressing mode, and all flags may be modified. Okay, so you need to write the example which I have shown here, as you need to consider, let the content of HL be something, and then let the data at that address be something, and then after the addition, what is the content after the execution. So I have not written the answer here. You need to find out after addition of 54 plus 22 plus 01. Okay. Okay, the next instruction is ACI 8-bit data. So what is the meaning of ACI 8-bit data? Add the contents of accumulator with immediate data along with carry. So here A plus immediate data plus carry, which is put back the result into accumulator. Okay, so ACI and 8-bit data. So there are 2 bytes which gives the full meaning to this instruction. That's why it is a 2-byte instruction. Since there is a immediate data, that's why the addressing mode is immediate addressing mode. And arithmetic group, as we know, all flags may be modified. Okay, now this is the last instruction under the addition instruction. Okay, so the next topic that we are going to understand is the instructions under arithmetic group only, but all subtraction instructions. Okay, thank you.